and no access to the native CAD files. So in this type of use case, we have to deal with already tessellated models. Not the best case to use PiXYZ because, of course, the tessellation algorithm for PiXYZ is very an added value, but we have to deal and to face this use case or as best as we can. So to start with, anytime you open a model like this one, coming from a lead or a contact or a customer, several things to check. First, the quality of the model, if it looks great directly or not, if the normal are correct, and start looking for specific features. So mainly the number of occurrences, the number of triangles, of course. The first step also is the size of the file in megabyte. So these are indicators of the weight of your file and how it will run into Unity. Maybe I can ask some help from Frank and Oliver here. Can you give us some, I don't know, the limitations of CAD files to run in Unity in runtime or editor mode in terms of performances? So if you want to achieve 30 frames per second, what's the maximum size? If we want to do virtual reality, that means 60, 90 frames per second, what would be the maximum size? What would be the impact of materials and textures and collision, stuff like that? Do you have any benchmark?
So I would say right now a number between 5 and 10 million is good for a whole car, for most graphic cards in VR. And yeah, under 200 draw calls or 200 to 300. You can go up to 5. Oh no, maybe it's more like 2,000 or 3,000. So, but less than the less the better, of course.
Yeah, in terms of, I think draw call is usually the limitation more than the poly count. Because if you are over, say, 10,000 draw calls, then it doesn't matter which GPU you have, because the CPU is going to be the limit anyway.
Okay. So unfortunately, the draw calls is not something you can count into PiXYZ and visualize. It's really depending on the viewer, and Unity has its own viewer, and we are using a different one at PiXYZ. So I will give you some guidelines and tooltips to reduce the number of draw calls, but it goes through reducing the number of occurrences, reducing the number of triangles, and also simplifying here the product structure of your model, which are the most the things that can bring some more and more draw calls in Unity. So first, let's start maybe with the product structure. This is basically the way your data is built. So how the engineers or the designers have created their model. So every time you select a part, there is what we call an assembly on top of it. You can access it directly from PiXYZ here. So this one is pretty simple. It's basically a few nodes all listed in 1, 2, and 3 different assemblies. So it's a very simple product structure. We will see a more complex one later. So the lighter this product structure is, the better it is for draw calls. So if you have 1, 2, 3, 5, 10 different levels in your hierarchy, that will start to be an issue for the performances in Unity. So we have features inside PiXYZ to simplify the product hierarchy. Everything is yeah.
So why did you say that the more complex the hierarchy is, it can what's the relation between that and performance in Unity?
So here, maybe I can get some help from the tech guys at Unity, but basically here it's very simple to access this part, because if I'm going to parse, to navigate through my product structure, is only 1, 2, 3, and 4 steps, let's say.
Oh, okay. So and then it's gonna end up being the same hierarchy in Unity?
Yeah, exactly. Okay, Unity is preserving also the hierarchy, but in CATIA, you can have hierarchy that goes up to 30, 40 levels like this one. So accessing the final elements, the part at the bottom of the hierarchy, costs time and performances. I don't know exactly why your viewer is more sensitive to this deepness than PiXYZ. I don't have this level of qualification and information, but maybe someone